Introduction. Students, look at these two sets. What can you say about these two sets?
These both are equal sets.
Very good. A and B are equal sets. Now, if we take this set C, what can we say about this? The set C is a subset of set B and set A.
Teacher, what is a subset?
Come, I will teach you. Objectives. At the end of this lesson, you will be able to explain subsets, define power set, learn universal set, explain Venn diagrams, write operations on set. Subsets. When we define a set, if we take pieces of that set, we can form what is called a subset. For example, we have the set 1, 2, 3, 4, 5. A subset of this is 1, 2, 3. Another subset is 3, 4. Or even another subset is 1. However, 1, 6 is not a subset since it contains an element 6 which is not in the parent set. In general, A is a subset of B if and only if every element of A is in B. Other definitions. A is a subset of or is included in B, denoted by this symbol. B is a superset of or includes A, denoted by this symbol. If A is a subset of B and B contains elements which are not in A, then A is a proper subset of B. If A is a proper subset of B, we use this symbol to designate that relationship. If A is not a subset of B, we write it this way to designate that relationship. If a set A has only one element, we call it a singleton set. Thus, A is a singleton set. Look at these symbols now. The first one means implies that, and the other one means if and only if. Intervals as subsets of R. A real interval is a set of real numbers with the property that any number that lies between two numbers in the set is also included in the set. For example, the set of all numbers x satisfying 0 less than or equal to x less than or equal to 1 is an interval which contains 0 and 1, as well as all numbers between them. Let A, B belong to R and A less than B. Then the set of real numbers y is such that A is less than y is less than B, is called an open interval and is denoted by A, B. All the points except A and B and between A and B belong to the open interval AB. The closed interval is denoted by this symbol. Closed interval is the interval which contains the endpoints also. Power set. If we have a set A, B, C, then a subset of it could be A or B, or AC, and so on. And A, B, C is also a subset of A, B, C. And the empty set is also a subset of A, B, C. PS is equal to A, B, C, A, B, A, C, B, C, A, B, C. If the original set has n members, then the power set will have 2 raised to power n members. Example: in the set A, B, C, there are 3 members A, B, and C. So, the power set should have 2 raised to power 3 is equal to 8, which it does. Universal set. Definition: the set that contains all the elements or objects involved in the problem under consideration is known as universal set. All other sets are subsets of the universal set. The universal set is usually denoted by U, and all its subsets by the letters A, B, C, etc. Example of universal set. For the set of all integers, the universal set can be the set of rational numbers. Venn diagram. Venn diagrams or set diagrams are diagrams that show all possible logical relations between a finite collection of sets. Venn diagrams were conceived around 1880 by John Venn. A Venn diagram is constructed with a collection of simple closed curves drawn in a plane. Illustrations of Venn diagram. To draw a Venn diagram, you first draw a rectangle which is called your universe. In the context of Venn diagrams, the universe is not everything, but everything you are dealing with right now. Let's deal with the following list of things: moles, swans, rabbit skunks, geese, worms, horses, Edmontosaurus, a variety of duck-billed dinosaurs, and a very fat cat. We'll call our universe animals. Let's say we want to classify things according to being small and furry or being a duck bill. We draw circles to display our classifications. Now we'll fill in or populate the diagram. Moles, rabbit skunks, and my cat are all small and furry. Swans, geese, and Edmontosaurus are all duckbills. Worms are small but not furry, and horses are furry but not small, and neither is a duckbill. However, they are animals. They fit inside our universe, but outside the circles. Operations on sets. The union of two sets A and B is the set containing those elements which are elements of A or elements of B. A union B can be written as this way. If A is equal to 3, 4, 6 and B is equal to 1, 2, 3, 5, 6, then A union B is equal to 1, 2, 3, 4, 5, 6. Example: if A is the set of prime numbers and B is the set of even numbers, then A union B is equal to X such that X is even or X is prime. If A is equal to X such that X greater than 5 and B is equal to X such that X less than 3, then A union B is equal to X such that X less than 3 or X greater than 5. Venn diagram. Union. A is represented by the red circle and B is represented by the blue circle. The union consists of all points which are colored red or blue or yellow. Some properties of the operation of union. Union is a commutative operation. A union B is equal to B union A. Union is an associative operation. A union B union C is equal to A union B union C. Law of identity element. Phi is the identity of union. A union phi is equal to A. Idempotent law. A union A is equal to A. Law of U. U union A is equal to U. Did you know? The power set is closely related to the binomial theorem. The number of sets with k elements in the power set of a set with n elements will be a combination n-c-k, also called a binomial coefficient. Summary. Let us summarize what we have learned. A set A is said to be subset of a set B if every element of A is also an element of B. Intervals are subsets of R. A power set of a set A is collection of all subsets of A. It is denoted by PA. The set that contains all the elements or objects involved in the problem under consideration is known as universal set. Venn diagrams or set diagrams are diagrams that show all possible logical relations between a finite collection of sets. The union of two sets A and B is the set of all those elements which are either in A or in B.